Hi, I'm Jackson,
And I'm Valor,
and we made a quantum eraser.
as part of AJ's group for the Deep 2025 showcase.
So, in our analogous quantum eraser experiment, what we're actually demonstrating here is we're taking a laser and shooting it into this lens. This lens replicates the double slit experiment, which gives us our end pattern. And then the laser goes into this beam splitter, and half of our light goes this way, and the other half goes this way. Each beam of light will go through a polarizer, which are initially set at the same angle, either 0 degrees or 90 degrees. And then the mirrors reflect all the light back to a second beam splitter, which again splits half the light this way and half the light this way. This beam of light goes through a third polarizer at 45 degrees to the first two polarizers. And then both beams of light hit a magnifying lens that lets our picture be seen better. The actual experiment here is we initially see this interference pattern in the light, but then what we do is we turn one of the polarizers 90 degrees to the other. And then when we do this, on the light that doesn't have the third polarizer, we lose our interference pattern and we just have light acting like particles. However, the light that goes through the third polarizer still has the pattern, even though we've revealed path information about it. So what we're demonstrating here with regular physics principles is the quantum principle of entanglement and path information.
So in this experiment, we made an analog for an actual quantum eraser setup, which is meant to show the wave-particle duality of quantum mechanics. So in an actual experiment, we would have a single photon source here. And what the single photon source would do is it'd emit a photon. The photon would go here, pass through a beam splitter, and it'd either be reflected or it'd pass through. If it's reflected, it goes this way and hits this mirror, and if it passes through, it goes this way and hits this mirror. So if it hits this mirror, it'll go this way, and if it hits this mirror, it'll go this way. Imagine that there's not a beam splitter here. If there's not, the photon will either be detected here if it was reflected on this mirror, or it will be detected here if it was reflected by this mirror. Now we put the beam splitter in. Since the beam splitter is in, we do not know which way the photon came from, since it can either pass through 50-50 or it can be reflected 50-50. But what ends up happening is that the photon is only ever detected here at this detector. So what is happening? The explanation that we have is that either whenever we put the beam splitter here, that somehow the present affected the past. The photon knew that we put the beam splitter there and it decided to be detected here. Or whenever it went through the path, it went through both paths simultaneously and interfered with itself in a wave nature and ended up only being detected here.